Ladies and gentlemen, fighting for us today, we have in the left corner the legendary, the long-lasted X58, represented today by the W3690 from Xeon. The system RAM is 24 gigs of 2055 CL9, and the graphics solution is a Vega 64 with 8 gigs of HBM2 memory. And in the right corner, we have the multi-talented, the future-proof X570, represented today by the 5950X from AMD. The system RAM is 32 gigs of 3600 CL18, and the graphics solution is NVIDIA RTX 3090 with a whopping 24 gigabytes of GDDR6X memory. These contenders will be fighting for us at 1080p, each under unique circumstances. Without further ado, right side, you ready? Left side, you ready? Touch gloves and come out swinging. I thought that'd be a pretty fun intro for us. So I don't quite have the rest of it so scripted, but I do have some scenes set up here. Now, there's a little bit of an odd comparison. I'm sure, a lot of people wouldn't be thinking, man, X570, X58, like, what do they have? Just a couple numbers in common, Like, what are you doing here? But the point I'm trying to make, the reason I'm making this comparison is because I actually find that these two systems, despite their large age gap, have actually really similar performance in modern titles at 1080p to some extent, to 1080p. The circumstances we're going to be doing this under is we are going to be upscaling. We're going to be fighting today in Cyberpunk 2077. We're just going to be running the benchmark. We're going to be using the performance setting from DLSS on our 3090 to render at 1080p and upscale that to 4K. And then we're going to have a native 1080p render from our Vega 64. And I'm not encouraging you to buy the X58 platform. That's not what this video is about. I just really enjoy both these systems, and I find these results just kind of interesting, and it really says a lot about how demanding 4K resolution, not even native 4K, this is upscaled 4K, and RTX features are, ray tracing, because boy howdy, would you not believe the results here. So without further ado, without further contemplation and conversation, let's get into it. Now, I'm going to migrate our scene over here, and let me launch Cyberpunk real quick, and hopefully that'll pick up fairly soon. I'm going to go ahead and transition the scene right away. You guys are going to see, the stock background for a second, but it'll all catch up there. Now, some of the things, too, that I find similar about these systems is that both of them were, like, the powerhouses of their time. They were unsurpassed in performance, and they had more cores and threads than people had ever seen and, frankly, knew what to do with at that time. Now, the X58 platform is a HEDT platform, so a high-end desktop platform. People would say this is like a professional grade, and nowadays you'd have Threadripper, but I would argue that the cost differences in the modern professional grade are so outstandingly large in comparison that I would really fit the X58 into more of an enthusiast grade consumer platform, even though there weren't more powerful chips at the time. People bought these as gaming setups, and they came with gaming motherboards and all that kind of stuff. So yeah, here we are. We finally got into the game, so let me switch over to that. We'll get into our menu here. And yeah, so like I said, both of them had more cores and threads than people knew what to do with. They were extremely dominant in their time, but both of them were quickly surpassed by the incoming chips. X79, X99, those surpassed X58 in a lot of ways. Let's take a break here to look at our graphics settings, because that's kind of important. So we got DLSS super resolution going. We're using the performance setting like I was saying. I've got the sharpening set to 0.25 just as a personal preference. Frame gen off, texture quality high. Everything else is pretty much maxed out. Ray tracing is ultra, path tracing is off. Everything else is just cranked, you know. So this is what we're looking at for settings. Here we're going to video. You can see we're at 4K. I'm going to put this over to windowed borderless because that's how it is in the other PC, and I don't know. We'll just do it that way. I don't really know if there's going to be a big performance difference or not. So with that said, let's get into the benchmark. Our first contender is getting ready to throw their punch. Let's see what they got. Mean right hook. Here we come. But and you know, it's the same thing with the X570, where, you know, it didn't take all that long for AM4 to come out. All of the things that, you know, X570 didn't have, you know, AM4 didn't have, AM5 did. DDR5 memory, you know, having the X3D available on the top end chips, different features like this. Now, I think that the X570 platform is, I guess what I would say, it's the modern budget. I mean, and it's been this way for a long time. It's been affordable for a long time. It's had powerful chips for a long time. I mean, what an amazing and still relevant platform. I mean, you know, we're not going to be seeing any new processors, and we did get a handful of X3D chips that came out right there at the end of its product life, which was really neat to see. Love seeing the 5700 X3D. Just nice to have that availability added, you know. And then, you know, also, you know, 12, 13, 14 gen from Intel. They've had some trouble over the years, as I'm sure you're all aware, but, you know, with 12th gen's always represented stability, you know, as kind of like, you know, the peak of that architecture, so to speak, you know, like when it was the most stable, I suppose. And, you know, the 14900K is still unsurpassed in performance, you know what I mean? So these are platforms that, despite they came out, you know, at this point almost 5 years ago, they remained incredibly relevant today. And I think they're going to remain relevant even longer than platforms like the X58 did, even though the X58 also just, I mean, I was gaming on it from 2010 to probably about 2019, like literally, like 2017, 2019. So let's take a look at our results here. We're looking at 45 average frames with a minimum of 42 and a max of 49. So I wouldn't call this like what, I mean, even though this is a single player game, I'm not going to say this is unplayable. Our frame times are smooth. However, I really would not want to see 45 FPS in, you know, in a fast-paced game like this, you know, where, you know, you really want to get the most out of the experience and not have any kind of, you know, lag or slowdowns or blur or anything, sort of thing like that. I really prefer to see this game running from in the, I guess, 50 at the low to the 70 FPS range. I think that's a much more comfortable range for it. But that's one of the things that makes this comparison so interesting. So that's our results with ray tracing included, maxed out settings, you know, at 1080p upscaled to 4K. This is the results. So let's switch back, and then we're gonna take a look here now at our next PC. Let me make sure that one's ready to go for you. Oh, get that one booted up. Okay, I'm gonna transition over to there. All right, so yeah, you guys are about to see how comparable these results are with just ray tracing and, you know, upscaling to 4K added on top of it. Now, admittedly, it is a little bit worse. However, you know, with this particular platform, although this isn't relevant to the comparison, I just put on quality FSR and I have a great time. I wanted more similar numbers, so I decided to do it as a 1080p render test, and I thought that gave closer results that were kind of more interesting in a sense. And the point of this video, besides, you know, kind of showing off these legendary cool systems, you know, with their high-end chips and high-end, you know, graphics cards and stuff like that, is just to show how utterly demanding ray tracing and high resolutions are. I mean, it's honestly kind of tough to understand in some sense, and in my opinion, it gives credence to the idea of AI upscaling, because here's my philosophy. I like efficiency. And let's take a quick break to look at our settings. All right, so here we got, we're going to set this to native AA, like I said, because this is a 1080p render test. The only difference really is that the crowd density is at low, and we've got no ray tracing features. We've got the FSR sharpening set to 0.75, probably not necessary for the native rendering, but I do like that setting for other kinds of FSR. And then otherwise, we're using pretty much the same settings. Everything is turned up to max. The only real difference is that, like I said, our crowd density is low, because that is going to skew our results somewhat, and we really can't expect these two CPUs to perform the same way in that regard. That's just not realistic. So like I said, this is a 1080p test. There's our settings. VSync is off. Let's go ahead and run that benchmark. See if I can pick up on my old train of thought. Yeah, no, it is. It's ridiculously demanding. And like I said, I believe in efficiency. And in my mind, if we've already processed a computation, it's redundant and inefficient to process it again, is my opinion. Whoa, we've got some great frames here. I almost can't believe, did I not adjust those settings? We might have to run this test again. I apologize. I'll try to monologue a little bit for us. Um, so, you know, yeah, like I said, if a computation's been completed, I really don't think it's necessary to continue to do this computation again and again and again. And I even think this philosophy extends to all sorts of software and apps. Um, your CPU is rendering everything, it's processing everything in real time every time. You know what I mean? It's got things stored in its memory, sure, but it still has to, kind of go about this inefficient process. Now, I think for applications, we might start to see more things like compute in memory as something, within smartphones. Right now, that also kind of takes a lot of power. But ultimately, I think we're going to boil down memory and computation together for lower powered tasks. And all of this is going to have an MPU backbone. Let's go back to our settings page here and make sure we're doing this. We got these settings right. So native, AA, no frame gen, high textures. Holy crap. Everything else is up. I had the settings right. That's absurd. So when I was doing this test yesterday, we'll run that again just for fun. When I was doing this test yesterday, I was seeing more in the range of like 35, but I'm not really sure why it would be so much higher. That doesn't really make a lot of sense to me. 1080p. Now, we are recording our X58 system off of a Elgato HD capture card, and I am having the X570 platform handle all of the OBS software, so that could be factoring in some way. To be honest, oh, Daphne. To be honest, I don't think that's, for a chip like a 5950X, I don't think that running this software, um, even the 3090, I don't think, that running this is really going to be this issue. But we're just seeing incredible results here. I mean, incredible results. So this adds even more weight to my argument. I mean, there's a near almost 300% performance gulf between these two chips. So that's just showing you like what a massive difference it makes to be trying to run these new features. I mean, I'm properly blown away, like that's astounding. We're getting almost 70 FPS running max settings at native 1080p with a Vega 64. My mind is blown in Cyberpunk. And yeah, so I mean, that's the results we're getting, folks. But what else can we say about that? Yeah, so like I was saying, I think that AI is going to play a bigger role. Right now we're seeing these in between, these fake frames where AI is, generating a frame based off of a pre-rendered frame and then extrapolating that into multiple different frames for frame generation. Now, what I think we're going to start to see more of is AI being built into game design and game rendering in a lot more ways. I think that, we already have procedurally generated textures and environments and stuff like that, and I think we're going to see that expand. A lot of people don't like that. A lot of people would prefer an artist to be doing everything, but I think that we have to admit that it takes a massive amount of time to make modern games, and I think that we want bigger games. I do. I think that, eventually we're going to be moving back towards an MMO style game, but just with more gameplay potential, more features, more options. And I think that AI is going to help us streamline development and also rendering. And so, in the way of rendering, I think that AI is going to play a role in rendering textures, especially, and also just trying to have memory of things that have already been computed, and then the AI is going to reference that and kind of input it into the graphic solution. And so, or the scene, I should say. So they'll have an object, something that's in memory, something that's already been computed, it's already been handled, and I think we might even see like some kind of background compute where the AI might be generating frames in different directions. Like say you move left or right, and that would affect shadows in an A/B way. You know what I mean? That once AI gets fast enough and the rendering gets fast enough, the processing gets fast enough, that is what's going to improve the smoothness. That's what's going to improve the latency factor, is that it's actually going to have options of what direction to go. It's not going to feel goofy in some sense. So, my anticipation is that to get 4K, to get 1440, with high refresh rates, with ray tracing, with all these features, I think that rendering graphics as we are knowing it today is going to fundamentally change at some point, and we're already starting to see the precursors of that. Now, this might not be for a while. This might be more of a 5 to 7 year window, that could be happening in. But I do think that ultimately that is something that is going to happen, because AI is the technology that we are developing. And as much as we're expanding hardware, we're also reaching hardware limitations. And so we're going to have to come up with more clever ways to integrate data, where we can have multiple different processors, because we've reached a speed cap, we've reached a process node cap, we're going to reach a cost cap if we keep trying to push those functions. And so I think what we're going to see is a focus of multiple different processing, happening at different levels. We're already starting to see that with different kinds of cores within GPUs, even different kinds of cores within CPUs, having efficiency cores, and just an overall larger integration of the whole computer package. This will probably result in new motherboards ultimately, where we'll see a different kind of RAM that more closely ties together graphics and processing and AI workloads. So kind of an odd direction to go, from what I was saying earlier, just like, how we started this video. Probably wouldn't have expected this, but that is my rant. And I have something really special I want to show you. If you're willing to stick around, I want to show you these PCs because I'm very proud of them. I think they're super cool, but it's also going to get a little bit messy because I got to pick up the camera and move you around a little bit. So let me back out of Cyberpunk here, just so you guys don't have crazy fan noise that you've got to listen to. And I'm going to switch the scene over one more time to a big version of me. You had a warning. And I'm going to grab the camera and we'll check out these PCs here because I'm very proud of them. Oh, Daphne's coming up again. Hey, Daphne. Oh, sorry, baby. What do you need? I know. I'll give you attention here in a second, okay? Let me finish my video, baby. Alrighty. So yeah, I've got a Cosmos 2 case. That's what this bad boy's sitting in. I found this thing. This was like the case I'd always wanted from high school. Just drool-worthy thing. And I found one in the cities near me. for a very good price. And so I, of course, had to snap it up and throw this modern system into this old school platform, this old school box here. Now, I absolutely love the way this computer turned out. It's a little tough to see, but I tried to do a heckin' great job with the cabling on it. And it's got such large fans, the thing actually runs pretty quietly. And I think it looks gorgeous. Like how I arranged all the cables. Yeah, it's a very, very pretty unit here. And now we're going to check out our X58 platform. So now, this isn't the motherboard I started with, but my first PC was the X58 platform. And I originally had an EVGA SLI3 board. And now I've got this Asus board because I just really wanted it back again. And I went and got this Vega 64 Red Devil edition for it because I just thought it matched the system perfectly. I thought it looked so cool. I got the Corsair memory cooler on there because I thought it needed a little bit extra help. And this thing ran hot. I mean, cooling this whole system down, it's a power-hungry system. I didn't really touch on it in the video, but both these computers, that one and this one, basically consume the same amount of electricity, but just have like a 300% difference in their performance, almost between the CPU and the GPU both. So I find that kind of fascinating as well. But yeah, I had to throw these fans in here, that fan in there. I've got this fan up there, and all of these are necessary to keep this system cool with the ridiculous overclock and all that I've got on it. So with all that said, thank you for joining me for this video. I thought it was just kind of a fun idea. It was a concept I kind of wanted to explore. I noticed a similarity in the performance between these, and I wanted to make a point that I'd made in some other videos about just how ridiculously difficult it is to do ray trace rendering at high refresh rates at high resolutions. I mean, we are pushing computing as we know it to the limits right now to try and accomplish that. It's fascinating that gaming is what does it. Like, out of all the things you could do on a computer, who would think that just playing games would require what it does? But don't I love it? It is such a fascinating thing. And with that said, with the comparisons made, with the fight accomplished, and X58 standing as the clear winner, in a sense, I think I'm going to wrap this video up. I appreciate you joining me. Like I said before, you take care of yourself, and I'll do the same.